So let's focus on this mystery function. As we said, it takes two arrays as arguments and their respective lengths. But as I mentioned in the previous video, there's something interesting going on in the main function when I call this mystery function. Notice that I have only declared a single array of length 5 in the main. And when I call the mystery function, I give it this array as the x1 array, but then I tell it it has length 3. This means that we are essentially telling the mystery function that x1 consists of just the first 3 integers in this array, which is 1, 3, and 3. The x2 array uses pointer arithmetic notation. Array plus 2, we know, is the base address of this array plus 2, which is the address of the 2th element in the array. This is the 0th element, the 1th element, the 2th element. So array plus 2 is the address of the second 3, which means the x2 array starts from here and it has length 3. So the x2 array consists of the last 3 numbers amongst this array of 5 numbers. So when we visualize this code, we will actually see this quite clearly. So here is the array with these 5 elements. Now when we call the mystery function, it is expecting 2 pointers, and we know that n1 and n2 are both going to be 3. x1 is array itself, so we are expecting this x1 to be pointing to the beginning of the array exactly as we have seen. The interesting thing is going to be x2. So when we click next and we follow this pointer, you can see that x2 is pointing to the second of the 2 3s, the element at position 2 in this array. So x1 is the first 3 elements and x2 is the next 3 elements. It's worth confirming that you understand this pointer notation using this code as an example. What I'm going to do is simplify it a little bit. I'm just going to call it array 1 of size 3, which consists of the first 3 integers, and then I'm going to separately declare an array 2 which also has 3 elements. This will just make it a little bit easier to see the visualization. The 3 was common to both arrays, so I'm going to add it over here, and now I'm going to say there's array 1 of size 3 and array 2 of size 3. This should produce exactly the same answer, but it's useful to take a look at the original version as well. Notice that the 2 arrays are consts, so I don't modify any of the values. The fact that the 2 arrays are now different is going to have no effect. If this function was actually modifying the arrays, then there might be a behavioral difference between this version of the code and the original one, because the original one was dealing with the same array and there was one element that was in common. Alright, so let's step through this version of the code and see if we can understand what's going on. So we've made our life a little bit easier. We now have these 2 different arrays, and when I call the mystery function, x1 will be pointing to the first array and x2 will be pointing to the second array. Right, we start our nested loops, and as we know, the values of I will change slowly, starting with I equal to 0, whereas the values of j will change relatively quickly. So here I is initialized to 0 and we're ready to start the inner loop. Notice that j only came into existence when we entered the inner loop. So now j is 0. There is no condition at all for j, so we've directly entered this body of the loop, and now we're checking if j is greater than or equal to n2. Well, n2 is 3, so this is not true. We will come to the else case, and we will check if x1 of 0, which is 1, is equal to x2 of 0, which is 3. They're not equal, so we will skip the else, which will bring us to the end of the for loop, and so we will jump up to the top. We will increment j, so j is now 1, and since there is no condition, we will enter the body of the for loop, the inner for loop. Now, because there is no condition, unfortunately, Python Tutor makes a little bit of a mistake in how it shows the next step. We should be entering this point, but Python Tutor actually jumps us to the end of the for loop, and then it realizes that actually we should have been here. So this is a small bug in the visualization. It really doesn't jump to the end and come here. We have no condition at all, so we can just come in here directly. Now, once again, we check this j. It's not greater than or equal to 2. And we check if x1 of I, remember I is still 0. So is x1 of I equal to x2 of j, which is now 1. So you can see what's going on. We are searching for this 1 in this array. As we are increasing j, we check this 1 against the 3. It was not equal. We check this 1 against the 2 now, and we're finding it's not equal. So we'll increase the value of j. J will now become 2, which is still going to be less than n2. So this if condition is not true. Now we find that this 1 matches this 1. x1 of 0 matches x2 of 2. So this is true. And now we're going to break. And recall that break will exit the innermost for loop. So this is the last statement in the innermost for loop. And what break is going to do is get us out of here. Now it is going to get us out of the loop that ends on line 12, which means we'll get to it'll get us out of the loop that ends on line 11 and get us to line 12. But line 12 is the end of the outer loop. So we'll actually end up jumping back to the next iteration of the outer loop. So when I click next, you will see that the visualization jumps over here. We're now ready to increase the value of I, which was 0 all this time, but now it's going to become 1, and that is less than n1. Now we're back inside the inner loop. J has been freshly created, this visualization, but it should be initialized not to 2 but to 0. The reason it was showing 2 is because previously j happened to have the value 2 when we ended the previous loop. But this is the initialization, it's done. And now we are ready to check if j is greater than or equal to n2. It is not, so we will proceed. And now, if our intuition is correct, we should be searching for this 3 in this array. Well, we're going to find it right away at position 0 in this array. So this condition is immediately true for I equal to 1 and j equal to 0, which is what we have here. So once again, we will break out of this loop, jump back to the next iteration. We will increase I to 2. That's still less than n1. We will reinitialize j to 0. And once again, this condition is not true, but when we come here to the else case, we will find once again that the element at position 2 does match the 0th element. So we were able to successfully find each of these 3 items in this array. Both of these were available right here at position 0. So since these are equal, we break. And now when we try and increase the value of I, since I will become 3, it's no longer going to be less than n1, and so the outer loop is going to finish, and this function is going to return 1. So you notice this function either returns 1 or it returns 0. It returns 1, it seems, when all the elements of the first array can be found in the second array. When does it return 0? Well, if it can't find an element in the second array, what's going to happen? J is going to increase until it becomes greater than or equal to the length of the second array. At that point, we're going to return 0. So it's now clear to us that this function is going to return 1 if it can find a copy of every item in the first array inside the second array. And if there's even one item in the first array for which it cannot find a copy in the second array, then it will return 0. This is very similar to the idea of a subset, where all the elements in one set are also inside the second set. Of course, these are arrays, they're not sets. So as you can see, there can be duplicate items which are not allowed in a mathematical set. And also these items are indexed, so there is an order to them, which isn't the case in a mathematical set. But it's a very similar idea. It is basically checking if all the items in the first array also appear at least once in the second array. And you can confirm this by trying out some other inputs. I encourage you to try out values, for example, like this. And this 4 does not appear in the second array. And you can confirm that in that case, this function returns 0. So there were many things that we saw in this one demo. As usual, please do play around with the data, play around with the code. And remember that in the original version, we actually had everything in one array. I encourage you to actually try running that original code once. It does become a little bit confusing to figure out what x2 of 0 and x2 of 1 are, because x2 is pointing somewhere in the middle of the original array of length 5. But if you can try it out, you will get greater confidence in understanding this idea of pointers and pointer arithmetic.